What was that?
That was electrostatic force.
Wait, who are you?
I am Professor Z.
Professor Z?
It's a work in progress.
Oh, okay.
Nice to meet you.
Hi. Wait, just now you said something about
Electrostatic force.
Oh, electrostatic force. What is that?
Well, in our world, there are negative charges and positive charges all around us, on every object, on every surface, even on the ground. So, when two objects rub against each other, charged particles will jump from one object to another, causing electrostatic charges to be produced.
Oh, so that means that the air particles from the air conditioner rub against my shirt, that makes me feel an electric light shock. This is because
Electrostatic charges are produced.
But Professor, what happened to the jumping particles?
Well, since only negative charges can jump while positive charges remain idle, one object will lose negative charges and become positively charged, while the other gains those negative charges and become negatively charged.
Ah. Do you have any
Experiments? Yes, I do. Now here's the interesting part. When two objects with the same charges come in contact, they will repel each other, while two objects with different charges will attract each other. Do you understand?
Yes. Oh, that was a lot of thunder.
Lightning also applies to this concept.
How is that?
Well, when clouds in the sky rub against each other or the air around them, charged particles will start jumping from one cloud to another, causing electrostatic charges to be produced that forms lightning.
Professor, how does lightning strike?
Well, when there's an accumulation of positively charged particles on the ground, it will cause negative charges to accumulate under the clouds, right above them. Now these negatively charged particles will start jumping to those positive charges on the ground. This causes lightning to strike at that spot.
Usually, lightning will only strike on high grounds, am I right?
Correct. If I put a building in this situation, lightning is more likely to strike at the highest point of the building because negative charges can only jump to an object with the closest distance from it.
But won't it cause fire?
That's why conductors exist. Now, have you ever noticed those rods on most buildings?
Oh yes, I do.
Now, they act as the conductor. Now, these rods are made of highly conductive metal. Since they are closer to the clouds, lightning is more likely to strike them. So their main function is to conduct any electrostatic charges produced and safely flow it through the building and into the ground, preventing the building from any damage from lightning. This also applies to tankers. When a tanker is in motion, the cylindrical shape of the tanker rubs against the air around them, causing electrostatic charges to be produced. And since tankers are made out of metal, these charges will be conducted throughout the tanker and may ignite the petroleum inside. So that's why chains are attached to the back of them.
Oh, so if the chain is a conductor, so it can direct the excessive charge to the ground, which can prevent a spark to happen that can ignite the petroleum.
Correct. Correct.
But Professor, what are other technologies that use this concept?
Well,
many of them know that much of our technology have used this electrostatic concept. We can see this electro-basic concept in photosynthetsis machine and spark plug.
Those two are the examples that is given aside. Other than that, this concept also applied on when an aeroplane is landing, the laser printer and the air filter. Lastly, we would like to thank the man who discovered this concept, that is Sir John Canty.
alright, thank you assistants. We now thank science for inspiring us to discover more about life. Now, do you understand the subject?
Absolutely.
Well, our work here is done.